Hello everyone and welcome back to our course. In the previous lecture we learned how we can predict price with Facebook Profit, and coming up in this lecture we're going to learn how we can analyze and visualize the model's performance. Okay, we're going to start with cross-validation. So I'm going to create a new code cell here and I'm going to import from Profit the cross-validation function. So from Facebook Profit dot diagnostics, this allows us to get diagnostics about our model. I'm going to import cross-validation. Then I'm going to create here cross-validation. I'm going to call the function. I'm going to pass in here first my model. Then I can pass in an initial here, which is going to tell me how many days I want. I'm going to do 900 days. Our period is going to be, let's do 50 days, and our horizon is going to be 100 days. All right, so the horizon is the total interval. Initially we had 900 and the period is going to be showing us every 50. The result of this is the cross-validation of our data frame. So we can call this data frame cross-validation. Then we can paste out the results, which is going to be a data frame itself. So let me here paste that variable and run this code cell. Just give it a moment, and once it finishes its 18 runs, we'll see our results. So here we can see the profit is making 18 forecasts with cutoffs between 2018 of here July 27th and 2020 November 23rd. All right, so just give it a moment to complete all of its epochs. If you want your cells to run faster, you can also go to runtime, hit change runtime type, and enable a GPU. That's optional if you'd like for the models to run faster. Awesome. Okay, and once you get this 100% notice with the green bar, that means you've finished completely. So this time, the results of our data frame actually begin in 2018 in July instead of 2016, which was the beginning of our initial data set. And as well, it ends at here, March 3rd, 2021, which is where we ended as well. All right, and here we have a lot fewer columns this time, only 6 columns, the date, the y-hat, as well as the range of the y-hat, and the actual y here from our initial data set. Okay, next up, we are going to see our performance metrics, or our error of our model. So let's create a new code cell here. And from Facebook Profit.diagnostics, I'm going to this time import the function performance metrics. Then I'm going to call that performance metrics function. In here, I'm actually passing in my cross-validation data frame. All right, and the result here is going to be our performance data frame. Then I can paste that variable and run the code cell. And look at this. Now we get a different data frame of different columns. So let's take a look at all of these. We have 91 rows by 7 columns. So here we have the horizon beginning at 10 days and going up to 100 days. This horizon is the agent's time to live. So if the number of steps an agent has left is changed, then the agent will behave differently depending on how many steps it has left. So this is the length of the agent's lifespan. Next we have MSE. MSE, also known as mean squared error. This is a way to calculate the error of our model. Then we have RMSE, which stands for root mean squared error. So all of these are just different ways of calculating error. MAE, that is mean absolute error. This is a model evaluation metric often used with regression models like linear regression. We have MAPE, our next column here. That is mean absolute percentage error. And that is going to here give us this value as a decimal, but it can actually be a percentage. Then we have MDAE, PE, that is median absolute percentage error, which is the middle value of all of the percentage errors for a data set. And finally, we have coverage. This is the portion of the data set for which a classifier makes a prediction. Because if the classifier doesn't classify all instances, we may need to know the performance on a set of cases. This refers to the set of cases for which it is confident enough to make a prediction. And this also is like a fraction. So for example, 50% of the data set, the classifier is confident enough to make a prediction. So these are all different ways to measure the error of our model. Let's take one of these values, like perhaps MAE or MAPE, and let's plot it in a visualization. So I'm going to make a new code cell here. From Facebook-profit.plot, I'm going to import a function to plot our cross-validation. This is different from Matplotlib or pyplot. I'm importing plot cross-validation metric. This will be a really easy way for us to plot our cross-validation. So I'm going to call plot cross-validation metric. Here I'm going to paste in my data frame cross-validation. All right, and we can see here data frame cross-validation. And from this, we can actually grab different metrics than the data frame itself. For example, we could grab, let's see what did I just do. We could grab one of the columns in the performance data frame, like mean squared error, right? And I can pass that in as my metric argument and then run the code cell. The result is going to be this graph. So on the y-axis, we have the mean squared error. On the x-axis, we have the horizon, or the days. We have all the data points representing our data, and we have our line of error. Right? Here we go. And here is just duplicated, but don't worry about that. They are the same. Okay, we can also plot other metrics. For example, you can plot all of these really. Let's do RMSE next. We just have to change the metric and rerun the code cell. This time we get RMSE, also known as root mean squared error or root mean square deviation. All right, so we can get RMSE versus days. We can do this for every metric. So let's do MAE and MAPE as well. So I'm just going to copy that code cell and pass in here. Oh, didn't mean to open that. I'm going to pass in here, not my CSV file, but my MAE, or mean absolute error. All right, here we go. Next, we had a different metric, which was our MAPE, mean absolute percentage error. You can see here. And one more we had our MDAPE, or our median absolute percentage error. And there we go. So we can see all the different values that we get for error. All right, coming up, we are going to next visualize our model's results, so we can actually see what the model managed to forecast. And we can compare that with the actual values that we have in our data set. So join me coming up in our next lecture. That's going to give us an even better understanding of how the model performed, because we're going to have a graph where we will have two lines, one for the model's prediction and one for the actual data set. Join me in the next lecture.